Welcome students. So far we have discussed about the one type of matter, that's pure substances, in which we discussed about elements and compounds, and elements and compounds are pure substances. Now today we are going to discuss another type of matter, that is mixtures. So student, what is a mixture? A mixture is a substance which consists of two or more elements or compounds not chemically combined together. So it means we are having a mixture in which we have mixed two or more elements or compounds. But those elements or compounds are not mixed chemically, they are not combined chemically. So for example, if you are having air, air is also a mixture. As mixture of gases, oxygen, nitrogen, argon, carbon dioxide, water vapor, a lot of things are there present in air. So air is nothing but a mixture. And you know what? All the gases of air, they are not chemically combined with one another. So air is a mixture. We are having another lot of example, like we are having gunpowder, that is a mixture of potassium nitrate, sulfur and charcoal, that is also a mixture. We are having an alloy, that's brass. Brass is an alloy which is made of copper and zinc mixed together. In fact, all the solutions are mixtures. Either is salt solution, where we have mixed salt with water. It's salt solution is also called brine. Okay, so sodium chloride in water, salt in water. That's also a kind of solution. Sugar solution, um, milk, ink, petrol, petroleum, coal, soil, wood, soap solution, alcohol and water, petrol and water, chalk water mixture, lemonade, vinegar, butter, shaving creams, fog, mist. These are all different examples of mixture. And let me tell you, the substances which are present in a mixture are known as constituents of the mixture or components of the mixture. Suppose if you are having air, air is made of oxygen, nitrogen, carbon dioxide. So these are called the components of the mixture, constituents of the mixture. If I am talking about gunpowder, gunpowder is made of potassium nitrate, sulfur, and charcoal. So these are nothing but the constituents of a mixture. Mixtures are of two types: homogeneous mixtures and heterogeneous mixtures. So let's discuss about homogeneous mixture. What are homogeneous mixtures? Those mixtures in which the substances are completely mixed together and are indistinguishable from one another are called homogeneous mixture. It means a homogeneous mixture is having a uniform composition throughout its mass. It will not have any visible boundaries of separation between various constituents. Mixtures indistinguishable. That is called a homogeneous mixture. So if we take an example of sugar and water, that is a homogeneous mixture because all the parts of sugar solution have the same sugar water composition and they appear to be equally sweet, right? You will not see any boundary there of separation there. There's no visible boundary of separation between sugar and water particles in a sugar solution. So solutions are nothing but homogeneous mixtures. A mixture of two miscible liquids is also a homogeneous mixture. Suppose I have mixed alcohol and water. That is also a homogeneous mixture. Um, our unpolluted air is also a homogeneous mixture of gases like oxygen, nitrogen, carbon dioxide. All the homogeneous mixtures are called solutions. So we are having a lot of homogeneous mixtures where a lot of solutions: sugar solution, salt solution, lemonade, soft drinks, petrol and oil mixture, alcohol and water mixture, sea water, kerosene oil, brass, vinegar, soda water. These are all but these are nothing but homogeneous mixtures. These are all solutions, and all the homogeneous mixtures are also called solutions. Okay. Now, what are heterogeneous mixture? See, hetero means actually other. Homo means same. In homogeneous mixture, we are having same composition. But in heterogeneous mixtures, these are those mixtures in which the substances remain separate, and one substance is separate throughout the other substance as small particles, as droplets, or as bubbles, and these are called heterogeneous mixtures. So basically, a heterogeneous mixture does not have uniform composition. It has visible boundaries of separation between the various constituents. You can see the particles separate as small particles, as droplets, as bubbles sometimes. So if you go for an example, we are having sugar and sand mixture. That is a heterogeneous mixture because different parts of this mixture will have different sugar sand composition. Some parts of the mixture will have more of sugar particles, but it might be possible that the other part will have more of sand particles. So there is a visible boundary. You can see the boundary of separation between sugar and sand particles. So suspensions of solids in liquid, that is also a heterogeneous mixture. You are not aware about suspension, you will get to know about it further. So if I have mixed sugar, I have mixed chalk and water. So you will see that you can see the visible boundaries of chalk and water. Chalk will not get dissolved. It will not form a uniform composition. Chalk particles are suspended in the water. So it's a heterogeneous mixture. A mixture which contains two or more immiscible liquids. That is also a heterogeneous mixture. Suppose petrol and water. You can clearly see the boundaries there. Not a uniform composition. So petrol and water is a heterogeneous mixture. You will learn after a while that all the suspensions and colloids are heterogeneous mixture. So we are having a lot of heterogeneous mixtures like sugar and sand mixture, salt and sand mixture, polluted air, milk, coal, soil, wood, our blood, dyes, petrol and water, chalk and water mixture, muddy river water, butter, cheese, fog, mist. These are all heterogeneous mixtures, and most of the mixtures are heterogeneous. Only solutions and alloys are homogeneous. Most of the mixtures are heterogeneous. Just only solutions and alloys are homogeneous mixtures. Now, what are the characteristics, what are the properties of mixtures? So, let me tell you that a mixture has the properties of its constituents. That means mixture shows the properties of all the constituents that are present in it. Suppose if I mix dilute sulfuric acid, if I mix sulfuric acid if I add sulfuric acid to the mixture of iron fillings and sulfur, we're having a mixture of iron fillings and sulfur, and I am adding sulfuric acid to it. Now, iron particles, they get reacted with sulfuric acid and hydrogen gas is produced. But sulfur remains unchanged there. So this shows that a mixture of iron and sulfur is showing the properties of iron when I am adding sulfuric acid to it. Now suppose now I am not adding sulfuric acid. Now I am adding carbon disulfide. I am not adding sulfuric acid. Now I am adding carbon disulfide to the same mixture of iron fillings and sulfur. Now you will see that sulfur dissolves in it, sulfur part dissolves in it, leaving the iron unchanged. Iron will remain like this, like it जैसे वो है, but the sulfur part gets dissolved in it. This means that a mixture of iron fillings and sulfur is showing the properties of sulfur now. So, if you combine the two results, you can say that a mixture of iron fillings and sulfur shows the properties of both of its constituents. It shows the properties of iron as well as the property of sulfur. So, we can say that a mixture shows the properties of all the constituents present in it. Whereas in case of compound is not showing the properties of its constituents because there is a chemical change. Constituents are mixed chemically. So new substances formed with new properties. So that is why compound does not show the property of its constituents, but a mixture shows the properties of all the constituents which are present in it. Now the next important characteristic is that when a mixture is produced, formed, little or no energy in the form of heat energy or light energy is given out or taken in. It means that uh, energy is usually neither given out nor absorbed in the preparation of a mixture. So you can say that formation of mixture is a physical change. It's a physical change because neither energy is given out nor absorbed. Energy can be in the form of heat and light. So if you do the same experiment, when iron fillings are mixed with sulfur powder to prepare the mixture, heat is neither evolved nor absorbed. So it's mixtures are formation of mixture is a physical change. One more characteristic is that a mixture can be separated into its constituents by physical means. Why by physical means we can separate them? Because they are not chemically combined, so we can separate them by physical processes. We can separate them by filtration, evaporation, sublimation, distillation, or any method, any physical method. But while in case of compounds, we cannot separate them by physical processes because constituents are combined together by chemical methods, by chemical form, right? They are chemically combined together, but in case of mixture where constituents are not combined chemically, so we can separate them by physical processes. Okay, so suppose if you are having a mixture of iron fillings and sulfur, and now you are putting a magnet in this mixture, iron particles get attracted by the magnet, they will stick to the magnet and get separated from sulfur, so we can separate that. Okay, in fact, if you use a liquid carbon disulfide there, then what happens, sulfur will dissolve in it and iron does not dissolve. Then on filtration, iron is obtained as a residue and sulfur is recovered from the filtrate by evaporating that carbon disulfide. So what I am trying to say is here that we can separate the mixtures by into its constituents by physical processes, but that is not the case of compounds. Another property of mixtures is that the components in a mixture can be mixed in any proportion by mass. That means we can mix any amount of components, any amount of constituents to get mixtures. We can have different composition of a mixture. So suppose I'm mixing iron fillings and sulfur powder. We can mix any amount of iron fillings and sulfur powder to get mixtures having different compositions. So you will have a mixture of variable compositions. And since the composition is variable, so no definite formula can be given to a mixture. So composition of mixtures are variable. The constituents can be present in any proportion, and that is why mixture does not have a definite formula. But in case of compounds, we are having a definite formula because the components are combined in definite proportion, right? One more characteristic is that a mixture does not have a definite melting point or boiling point, because they are having variable composition, so they are not having definite melting and boiling points. And mixtures are usually heterogeneous except solutions and alloys. As I told you, solutions and alloys are homogeneous mixtures, but most of the mixtures are usually heterogeneous. So this was all about mixtures.